So the first thing you're going to do is just read the question. A 10 milliliter sample of stock 12 molar HCl is diluted to 2500 milliliter. What is the pH of the resulting solution with the hint M1V1, M2V2? Okay, the first step on all these questions is always to be the same thing, is to write your H so it's legible. HCl goes to H plus and Cl minus. Write your dissociation equation. Let's see. So I'm after the pH. To find pH, I either need pOH or I might need the hydrogen ion concentration. The hydrogen ion concentration seems easier to get. So M1V1 equals M2V2. Let's see. In that, let's see, 10 milliliters of sample 12. So 10 milliliters at 12 molar equals some molarity at some volume. Now it's diluted 2.5 liters. Since this is in milliliters here, since 10 is in milliliters here, the 2500 needs to be in milliliters as well, not 2.5, but rather 2500. Solve for x, which is going to be 0.048. Okay, so that's a concentration. So that is the concentration of HCl is now equal to 0.048. Okay, so 0.48 is a concentration, so that's moles per liter. In this case, the hydrochloric acid here, HCl, disassociates into H+, and there's a 1 here and a 1 here. It's a 1-to-1 ratio. Because of that, I know that this is also equal to the concentration of hydrogen ions. Well, if I know the concentration of hydrogen ions, I'm like one step from pH. All I need to do is take the negative log of that concentration, 0.048, and that's going to give me the pH. So in this case, the pH comes out to a 1.31. Remember, pH is unitless. There's no units on pH. So our pH of this solution is 1.31. This is actually a really easy question compared to some of the other ones on the assignment. So if you see dilution, just be careful with the units is all you have to really watch. But otherwise, these are kind of the best case scenario. Like if you get this kind of question, you can do it in just a line or two and not have to show a whole lot of work. Where people would make mistakes in general is one of three things. Use the wrong volume here, make this 2.5. That would be a very common mistake. Set this equal to OH minus instead of H plus. The reason why it's H plus is that's up here in the dissociation equation. And a third mistake would be forgetting this negative sign when they hit their calculator and putting a negative 1.31 here. Relatively common mistake again. Just be careful. Make sure that your pH is always positive. We're not going to deal with anything that gets into a negative number. So that's really about it for this problem.